How are you?
Good. Who is talking? You have brother or sister?
I have a brother.
Good. So how was your school going, Amira? How was your week?
Yeah, it was fine.
You're going to school, right? Every day.
Yeah.
How many hours actually you stay at school? From 8 to
Uh,
4?
yeah.
8 to
Yeah, from
4. Oh, you must be very busy. Okay. But still, you must have missed your school a lot. For about 6 months, you stayed home, right? Since March. Okay. I don't know if you stay home for a long time. Also, actually, people may get used to it. They may not want to go out. This is what I see in my kids. I thought that they missed their school a lot, but actually they didn't.
Yeah.
Anyway, Amira, shall we start?
Mm-hmm.
Do you remember what we did the last time?
Sort of.
Okay. All right. You can see my screen, right?
Yeah.
Okay. I just prefer to keep my video on at least you can see me. Maybe I cannot see you. Because just looking at the screen and talking sometimes weird. At least I can see myself on the screen.
Yeah.
Anyway, so Amira, then let's start. As you remember, actually, we were talking about matrix. As I told you in secondary school, actually, we just teach or students learn how to add two matrices, how to subtract, and how to multiply matrix by a real number that is scalar. And after that, also the last time we studied actually how to multiply a matrix by another matrix. And also we learned that it doesn't have commutative property. That means that A times B is not equal to B times A. We saw that in some examples. And one more thing is left about matrix, and after that we will see. I think I'm going to finish this today, and after that we'll talk about some application of math in our daily situations or practical situations. Okay, so today we're going to solve, I mean, how to say, study or learn one application of matrix. Of course, it has a lot of applications and a lot of different, how to say, branches of science and physics and chemistry and engineering fields. They are used a lot. But here we are just going to see one application. That is how we use matrices to solve system of equations. When I say system of equations, we mean here linear equations. We may have two equations, three equations, four equations. Sometimes we may have a lot of equations, maybe 10. It doesn't matter. But here we're just going to get study this to get some, how to say, intuition about this application. How is it used to solve the system of, what is it, linear equations? Okay, so let's just start with this example. That's very simple example. We did a lot of questions like this. You know how to solve this, but here, again, once again, we're just going to practice how matrix is used to solve the system of linear equations. If you remember this kind of questions, actually, if 5 apples and 4 pears cost 4.30, while 4 apples and 7 pears cost 6.10, what is the cost of 1 apple and of 1 pear? So now, as you know, if you just use two variables here, right, for let's say one apple, it costs, let's say, X dollars or X cent, doesn't matter. And here one pear, it costs Y dollars. Now it says that 5 apples and 4 pears. So that is, here we have 5 apples and 4 pears. That is $4.30. And in the second part, it says that 7 pears cost, what is it? 4 apples and 7 pears. So 4 apples and 7 pears cost 6.10. And that is, what is it? Simultaneous linear equations. And also, if you remember, why do we say that these are linear equations? I mean, each equation, we have two equations. Each equation is a linear because each variable is multiplied by a constant number. In the equation, we do not have a product of two variables. Like, we don't have x times x, or we don't have x times y, or we don't have y times y. So that's why it's called linear. Or we don't have any kind of sine function like sine of x. Okay. And now, here, just this introduction, we'll practice a bit later. Now, in a very compact form, how can I just write this using a matrix? Now, see here we have 5 times x and 4 times y. And here we have 4 times x and 7 times y. Actually, I can just write it as a product of two matrices like this. Here, if I just write the coefficients of x and y here we have 5 and 4. If I just write here 5 and 4, and here we have 4 and 7. So here we have 4 and 7. And here we have another matrix that is x and the y. On the right-hand side, here we have 4.13, and the second component is 6.10. Actually, I can just write this system in this way. Actually, they both represent the same thing. Okay, this problem, either I can just represent using this simultaneous equations or this matrix equation. And if you just multiply, what do we have here? 5 times x plus 4 times y, right? If you just multiply the left-hand side, and here we have 5 times x, 5x plus 4y, here we have 4y. And 4 times x, here we have 4x plus 7 times y, that is 7 times y. On the right hand side, we have 2 by 1 matrix, 4.13 and 6.10. And we know that for two matrices to be equal to each other, they must have the same order. That means they must have the same size, and their corresponding entries or components must be equal to each other. So here, that is the first component. Since we are saying that the left-hand side equals right-hand side, this must be equal to this. So then that gives us the first equation here. And the second one, actually 4x plus 7y, it gives us the 6.10. That is 4x plus 7y equals 6.10. Okay. So, all right, to solve this one, we need to have some information about this. As you see here, again, actually we call this coefficient matrix because all the entries in this matrix, they are the coefficients of these variables. If I just denote this matrix by A, it's so bright. How about blue? Okay, A, then here we have something like this. A times, let's say this one as X. So here we have X. On the right hand side, we have another matrix. Let's say it is B, right? So how can I solve this equation? It is something like this, actually, in math. If you remember how they solve this equation, 3x plus 7, let's say, is equal to 2. First, we should eliminate this 7, right? How do we eliminate this 7? We should subtract 7 from both sides. So this 3x plus 7 minus 7 equals 2 minus 7. 7 minus 7, that's equal to 0. Here we have 3x, 2 minus 7, that is negative 5. Now we have to eliminate this 3. How do we eliminate this 3? Actually, we should multiply both sides by the multiplicative inverse of this 3. That is, I should multiply multiplicative inverse of 3. We call this reciprocal. Right? This reciprocal. So here also I should multiply this actually from left-hand side. Here we have 1 over 3 times, here we have minus 5. 1 over 3 times 3, that is 1 times x. Here we have negative 5 over 3. Now 1 times x equals x, so from here I can get x. X equals this. For the previous equation, we are going to do the same thing, but here we do not have a real number, a, that's a matrix. And also x, also it's a matrix. Also b, also that's a matrix. So the question comes then, how can I multiply both sides? Let's say here we have x, that's equal to, let's say b. something, I should multiply by something, so that here we will have identity element. Here we have 1, right? So I should multiply left hand side of each side by something so that I can have a. So let's say that is, let's say it is c. And also I should multiply here by c. And I'm hoping that here we have c times a. When I multiply these matrices together, I have this identity matrix. And if you remember this identity matrix, what is it? We're talking about this matrix that is 1, 0, 0, 1. It actually serves the same function as 1 in real number system. In real number system, identity element is 1. In matrix system, actually, identity element is this matrix. All the components in the main diagonal, they are 1s, and all other components or entries, they are 0s. Because if you multiply
Okay.
any matrix by I, it actually gives us that matrix itself. Because A times I equals I times A, that's equal to A. You can check this, it always gives us A. So actually, can we just find C? Actually, we are going to answer this question. How do we find this C? Actually, we are going to give a special name to this. We will call this the inverse of A. The C is denoted by this A inverse. So that means that A inverse times A will be equal to A times A inverse. Doesn't matter here. That's equal to I. Okay, so if I can find this number, I mean this inverse of A at the time to solve that equation, uh, let me just finish this, and after they will focus on finding that's inverse. So now here we have A times X is equal to B. I want to solve the system in just one step or maybe two steps. How can I do that? So if I multiply both sides by the inverse of A, I'm hoping that the inverse exists. It does not exist all the time. So here, if you just multiply by inverse of A, here we have X, that is our unknown. So here we have A inverse times B. Always we should keep in mind that we know that A times B is not equal to B times A. That's why multiplying on the left or on the right, actually they are different things. So here I'm actually multiplying on the left. A inverse, A inverse. If you multiply on the right, then I need to write it here, and also I need to write on the right-hand side of B. So A inverse A, by definition, is just equal to I, identity matrix, and here we have X, and here we have A inverse B. And what is I times X? Just itself, that's X, and here we have A inverse B. So the product of these two matrices, it just gives us the solution of this X. And that is how we solve the system of linear equations. We may have 2 equations, we may have 3 equations, we may have 100 equations, it doesn't matter. If it has one solution, see here, if we know how to find the inverse, actually in this way we can solve this system. That is one application of matrices in solving system of linear equations.
Okay.
So in some examples, you will see that that's very easy because here you're just dealing with only 2 by 2 matrices. When it is like 3 by 3, 4 by 4, it gets more complicated. Actually, it doesn't get complicated, but it actually involves a lot of calculation. And that's why even 3 by 3, it's not asked to secondary school students. You will study this at university when you take linear algebra or differential equations. Okay, so now we assume that we are given a matrix. Let's say we are given these matrix. Amiri, can you see this wall blue, or should I change the color?
The color's fine.
Okay, good. Because now I'm just trying, maybe black is not so bright, because sometimes if I use different color of the background, and sometimes I feel pain in my eyes, that's why. Now I'm trying this black background. And anyway, so Hamira, the main idea is if we are given a 2 by 2 matrix, let's say A, B, and C, D. Okay. The question is, how can I find another matrix? Let's say it is B, whose entries are W, X, Y, Z. So that actually it must satisfy this condition that A times B should be equal to B times A, it should be equal to I. how can I find this matrix B? This A is given, we need to find B. To answer this question, I have to solve this system. Since I'm assuming that this A times B equals I, so if you just multiply here A times B, what is A times B? That is A, B, and here we have C, D, and here we have W, X, and here we have Y, Z. On the right hand side, what we have I, identity matrix, that is 1, 0, 0, 1. So we know how to multiply this matrix. Let me try another color, maybe it is much better. So we know how to multiply these two matrices, A times. For example, if you just multiply the first row by the first column and the second column, it gives us the first row entries. Well, let me multiply by A times W. Here we have A, W, and BY plus BY. And here, that is the first entry. And if you multiply this first row by the second column, it gives us this entry. That is A times X. So here we have AX plus B times Z. That is BZ. And now the second row entries. So we should multiply the second row by each column. The second row by the first column, C times W. So here we have C times W plus D times Y. D times Y. And C times X, CX plus D times Z. D times Z. So multiplying 2 by 2 matrix by another 2 by 2 matrix, the result is 2 by 2 matrix. On the right hand side, we have nothing to do. So now we are claiming that these two matrices are equal to each other. That means that their corresponding entries must be equal to each other. And here we can see that actually they have the same sizes. So that means that that thing should be equal to 1. Let me just write here, AW plus BY is equal to 1. And here we have CW plus BY is equal to 0. In similar way, this should be equal to 0. This should be equal to 1. If we just solve this system, we know how to solve this. Actually, you will see that in the denominator, I'm not going to continue here, that much idea is enough for you, I think. We know how to solve the system in our usual way. If you solve this, actually, we will have this AD minus BC in the denominator. And when you just find this, you will see that this W will be equal to D minus that thing. And Y will be equal to, what is Y? Y will be equal to negative C over this thing. And everything, actually in the denominator, we will have this AD minus BC, right? Because as you know here, how can I eliminate this W, for example, or let's say Y here? So we should divide both sides by B, right? And also here we should divide both sides by D, and we should subtract. And here we have A, let me just show here, here we have A over B, W plus Y is equal to 1 over B. And here we have divide both sides by D, C over D, W plus Y is equal to 0. So if you subtract here, we have AB and CD. So in the denominator, we will have BD. And when you just substitute and anyway find the W, we will have something in the denominator AD minus BC. Okay, because here we have A times D, right? B times C. And when you just divide both sides by this coefficient, and we will have D over AD minus BC. Anyway, that is the main idea. So now, again, if you just solve this system, we will have that thing. Actually, that thing is equal to our B. That B is this. And we just call this, what is it? The inverse of A. And this is how we denote this. And provided that this AD minus BC is not equal to 0. When this A times D minus B times C is not equal to 0, then the given matrix has inverse. Otherwise, it doesn't have inverse. And also, actually, we'll just give a special name to this AD minus BC. That is called determinants of A. Okay. That is the main idea. So now let me just show you 2 examples. After that, I will give you the microphone and you will talk, I will listen. I already told for 20 minutes. Let's see one example here. Here, if A is equal to this and B is equal to this, find A times B and B times A. What can you conclude from your answers? And this question is put here on purpose that once again to show that A times B is not equal to B times A. Right? So here, if you just multiply A times B, what is A times B? Just write quickly. Here we have 4, 1, 11, 3. And here we have 3, negative 1, negative 11, 4. Okay. Amira, you tell me the components so that at least we'll get involved in the class.
Okay.
What is the first component here?
That's 4 times 3 plus 1 times negative 4.
Okay, 12 minus 4, that is 8. Okay, the second one?
4 times negative 1 plus 1 times 4.
Okay, that's equal to 0, right? 4 times negative 4, negative 4, 4. Okay, that's correct. Okay, this one?
And then 11 times 3 plus 3 times
33.
negative 4.
Okay, 33 minus 33, that's
Negative
equal
12.
to 0. Okay.
Yeah. And then 11 times negative 1 plus 3 times 4.
Okay, negative 11 plus 12, that is 1. Good. Now, how about B times A? B times A is 3, negative 1, negative 11, and 4. And here we have 4, 1, 11, 3. Okay. Okay, what is the first component?
12 plus negative 11.
12 plus negative 11, that is 1. Okay. Second one?
0.
0. Third one?
So negative 11 times 4 plus 4 times 11. So that's just 0.
0. And the last one?
Negative 11 plus 12, 1.
It's 1.
Yeah.
Did we calculate the first one correctly? Why? Okay, so okay, but because it's identity element, if it is I, also this must be I. This is 4 times 3, 12, and 1 times negative 11 minus 11, it should be 1, right?
Yeah.
Okay, this should be 1. Okay, we made a mistake. So now we know that actually we are familiar with this matrix that is identity element 1, 0, 0, 1. Also that is identity element. It said that what can you conclude from your answers? So actually here A times B equals B times A. So we can conclude that here A times B equals B times A if and only if, not if and only if, of course under some conditions they may be equal. So when actually that's equal to identity matrix.
Okay.
So now what do you notice here? Once again, that means that B is the inverse of A. That B is the inverse of A. Because when we say that A has an inverse, if A times its inverse is equal to I. Since A times B equals I, or B times A is equal to I, that means that B is the inverse of A. And also, if you just check by using the formula, for example, that B, how do you find that? First, okay, we'll just see it in the next example. If, okay, these three matrices are given, find A inverse, B inverse, and C inverse where possible. All right, now here, we know that to find the inverse, again, let me just write here, A equals A, B, C, D, and it is inverse equals 1 over A times D minus B times C. It's a determinant of A, D minus B, C. And here, what we have here, Amira, do you remember?
Not really.
Let's have a look. DA minus BC, because this one is easy to remember. This AD, they are interchanging, but these things are not changing, but just they are multiplied by -1. Of course, if you don't practice, you may forget this. Here we have D, here we have A. These things are interchanging, and here we are multiplied by -1. A, B, C, D. So here we have minus B, and here we have minus C. Okay, that's how we find the inverse. So first one, to find the inverse of A, and using this formula, that is equal to, first we need to calculate this AD minus BC, because if it is equal to 0, we don't have to continue, just write it, stop and write it, how to say, conclude that actually it doesn't have inverse. So number one, for A, determinant of A, that is 7 times 9, 7 times 9 minus 3 times 14, that is 3 times 14, 63 minus 42, which is equal to 21. Okay, it's not equal to 0, that means it has inverse. Then, what is the inverse of A? First question. So that is 1 over 21, that is AD minus BC. And here we have DA. So here we have 9, 7, here we have 9, and here we have 7. And the minus 3 minus 14. So minus 3 minus 14. Or I can just write it, bring this inside. So here we have 3 over 7, minus 3 over 21, minus 1 over 7, minus 14 over 21, minus 2 over 3, and 7 over 21, 1 over 3. Okay, this is how we find the inverse of the given matrix. What you have to know here is just to get some idea, and you should know this formula. I mean, I don't know that it's provided or not in the exam or anywhere. Only for exam you have to memorize this formula. In daily life, if you have to use this, anytime you can just have a look and use it. The important thing is to get the idea and some intuition about this concept. So Amira, can you do B?
I can try, yeah.
Okay. Yeah, you can do this. That's because just we need to apply the fixed rules here and okay, first let's find the determinant of B. I think you don't have to copy the matrix.
Is that correct so far?
Yeah, that's correct. Minus 6, minus 12, that is. Usually also you can just put 2 vertical bars, Amira, that means it's determinant of B.
Oh, okay.
The same thing. Okay, equals is negative 18, all right. Okay, now B inverse, okay, equals 1 over negative 18. We need to interchange, okay, A and D, that is minus 2 and 3, and multiply by 4, okay. And let's bring this negative 1 over 18 inside that matrix.
Does that mean I just times it by everything inside?
Sorry, say again?
Does that mean I just need to times it by everything inside?
Yeah, because 1 over minus 18 is just a scalar, right? Multiplying matrix by the scalar, that means we need to multiply each component or each entry by the scalar. So multiply each entry of the matrix by 1 over negative 18. So minus 1 over 18 times negative 2, that is 1 over 9, right? That's the first component. Okay, multiplies by 4.
What would this one be?
Yeah, minus 1 over 18 times 4. What is it? Minus 2 over 9. Okay, now minus 1 over 18 times 3, that is minus 1 over 6. Okay, that's also the same thing. Okay. So that's the
yeah.
inverse of B. Amiri, can you just check this to make sure that your product equals I? Can you just multiply your B by B inverse or B inverse by B? Because when it's inverse, when you just multiply together, it must give us I. B inverse, okay. When you are checking Amira, actually it's true or not, because sometimes you can make a technical mistake. You can use the first result. It's much easier because it's a scalar, right? If you remember, if you write something A, if it has scalar B, it's the same as C times A, B. So that is a scalar, right? I can just keep this out and only you have to multiply by integers here. It's much faster. Maybe next time, now you have already written here, you can multiply, but in case, for example, sometimes even when you find the inverse, to make sure that it is correct, you can just multiply and see, is it equal to I or not? So to check this one, if you use this one, it's much easier because all these numbers inside the bracket, these are integers, right? I can just give this constant here. And after we multiply these matrices together, then I can multiply by this scalar or by this constant.
Okay.
Three times 1 over 9 is 1 over 3. And minus 4 times minus 1 over 6, that is 2 over 3, right? The sum is 1. Okay.
Mm-hmm.
3 times minus 2 over 9, it is minus 2 over 3. And 2 over 3, that's equal to 0. Okay. And minus 3 times 1 over 9, minus 1 over 3, and 1 over 3, that's equal to 0. Okay, that's also correct. And the last one, minus 2 over 3 plus 1 over 3, that's correct. And actually, you will see that even since it is I, even if you just multiply on the left, like by B inverse times B, you will get the same results. Okay, that's good. Let's move to the next question. Let's do this question. After that, you will have break. Okay.
Mhm.
All right. Now we have the idea, and we know the formula how to find the inverse of a given matrix. It's 2 by 2 matrix. So now let's just apply this to solve this equation. It says that if A equals this and B equals this, write down the inverse of A and use it to find the matrices P and Q in the following equations. Good. So first step, we need to find the inverse of A. Let's talk about this A, this one. And to do this one, first let's just calculate the determinant of A. That is 1 times 7. That is 7 minus 2 times 3. That's 6. That's equal to 1. That's not equal to 0. It means that it has inverse. And what is the inverse of A? Inverse of A equals 1 over 1. We don't have to write 1. And so here we have D and A, they interchange. So here we have 7. Here we have 1. Here we have minus 2 and the minus 3. And here we have 1. That is the inverse of A. Okay. So now to solve this equation, A times P, that's equal to B, right? We know B, we know A. The question is we need to find P. How can we solve it? Actually, it's exactly similar with solving linear equations, but here we are just dealing with matrices. How can we leave this P alone here? I should multiply actually both sides by the inverse of A. So if I do so, since I know the inverse of A, let me multiply by inverse on the left, A inverse AP. I do the same thing to the right hand side, A inverse and B. But if you write here B, A inverse, it will be wrong. Since we are multiplying on the left, and also here we should multiply on the left. And what is A inverse times A? By definition, that's just equal to I. That is I times P. On the right, we have A inverse times B. That is identity element, I times P, that's just equal to P. So here we have P equals A inverse, and here equals B, times B. And we know what is A inverse is equal to this. So that is 7, negative 2, and negative 3, 1. And the B, that is 4, 2, 1, 3, which is equal to 7 times 4, 28, minus 2, that is 26, 7 times 2, 14, negative 2 times 3, it is negative 6, so that's equal to 8, negative 3 times 4, negative 12, 1 times 1, 1, it is minus 11, negative 3 times 2, negative 6, plus 3, that is negative 3. So the matrix P must be equal to this. Okay?
Okay.
Can you do B, Amira? After that,
Yeah.
we'll have break. Okay.
So we have the inverse of A already.
Yeah. Now let's multiply. What is B? Write the components of B. Equals, right? Equals 4, 2, 1, 3. A inverse 7 minus 2.
So that is 28 plus -6.
22. Okay. Seven minus 9, -2. Minus 2 plus 3, 1. Okay. So that is the matrix Q. So very easy, very simple. Okay, Amira, let's have some rest. After 10 minutes, we'll continue. Okay?
Okay.